In this video we're going to look at the standard equation of a hyperbola. We'll kind of learn about it through the use of an example. And so first of all, let me describe the standard hyperbola equation. The way I like to think of this is as a squared fraction minus a squared fraction equals 1. Okay? In an ellipse, it's the same thing except it's a squared fraction plus a squared fraction. Okay? So it looks something like this. You'll have one squared fraction minus another squared fraction equals 1. Okay? Now, you have a positive fraction and a negative fraction. So your positive fraction could be your x fraction, or your positive fraction could be your y fraction. Okay? And so if your positive fraction is the y or the x fraction, so let's say this, the positive fraction tells us which way the hyperbola opens. If the x fraction is positive, the hyperbola opens left and right, horizontally, okay? And vice versa. So, let's do this. If we go back up here, this equation is going to give us a hyperbola that opens left and right, like this. And if this is the equation, we have a hyperbola that opens up and down. Okay? So if the y fraction is positive, it's a vertical hyperbola. If the x fraction is positive, it's a horizontal hyperbola. Okay? Furthermore, the denominator of the x fraction, it gives us the horizontal distance. Okay? And of course that's squared as well, just like in an ellipse. So whatever number is under the x fraction is the horizontal distance squared. And whatever number is under the y fraction, of course, then would be the vertical distance squared in each case. Okay? The number under the x fraction gives the horizontal distance, and vice versa, meaning under the y fraction gives the vertical distance. Okay, now about a and b. In an ellipse, a is the bigger number, b is the smaller number. That's not true in a hyperbola. A comes from the positive fraction, and b comes from the negative fraction. Sometimes b is bigger than a. Okay? So it doesn't matter which number is bigger. B could be bigger, a could be bigger. It doesn't matter. It depends on which fraction is positive. Okay? So this is the idea behind the standard equation of a hyperbola, very similar to that of an ellipse. You've got a minus here, and now a comes from the positive fraction, not the bigger denominator. Alright, so let's do an example here. Okay, so I've got an equation here. I want to graph it and list all parts. It's a bit confusing because I don't have a squared fraction minus a squared fraction equals 1. However, I do have a negative squared fraction plus a positive squared fraction. So I could rewrite this and put the positive fraction first. And now it's a squared fraction minus a squared fraction equals 1. Okay? So we can get lots of things from this immediately. The information inside the squared parts will give us the center. Alright? So when I want to find the center, I take the x and y squared parts and figure out what makes them 0. So x plus 2 equals 0 means that x equals negative 2. And y plus 4, if that equals 0, y would be negative 4, giving us the center, the ordered pair negative 2, negative 4. So that's our center. So let's go ahead and graph that over here as we go. So negative 2, negative 4 is the center of this hyperbola. So I've used those now. And then the numbers underneath, those are going to give us our a and b values. Now a comes from the denominator of the positive fraction. So I know, and that's squared by the way. So a squared equals 25. That means a equals 5. Then I need to know what direction to measure a. By the way, all I did to get 5 was take the square root of both sides. Sometimes that's not a pretty number. This could have been 26. And then a would be square root of 26, which is a little bigger than 5, okay? But in this case, it came out very nicely. So a is 5. Since a is 5, and it's under the y fraction, I know that's a vertical distance, so I know that's going to be measured up and down. So for my center, I'll go 5 units up, so 1, 2, 3, 4, 5. And I'll go 5 units down, 1, 2, 3, 4, 5. And those are my vertices. So let's list those over here. The top vertex is the ordered pair negative 2, positive 1. And the bottom vertex is negative 2, negative 9. That also helps me see my transverse axis here, vertex to vertex. Okay? Now my other denominator is going to give me my b value. The denominator under the negative fraction will give me my b value. So I know b squared equals 16, and if I take the square root of both sides, I see that b is 4. B is measured in the opposite direction of A, so I need to go 4 units right and 4 units left. 1, 2, 3, 4. 1, 2, 3, 4. And that's my conjugate axis. And those two together give me my center rectangle. A and B together give me my center rectangle, which is here. Excellent. Alright, now I know A and B, I need to find C. So I know that, I'll do this in red so it kind of stands out. I know C squared equals A squared plus B squared for a hyperbola. So I plug in the A value that I have and the B value that I have, or in fact I even know that A squared is 25 and B squared is 16. So I can plug in, for A squared I can plug in 25, and for B squared I can plug in 16. So C squared equals 25 plus 16, which is 41, which means that C is the square root of 41, which equals 6 point something. Okay? I don't really need to be more precise than that for graphing. I also know that C is measured in the same direction as A. It's along the transverse axis. It's going to give me my foci. So this will be measured up and down. Okay? So for my center, I go a little more than 6 units up. 1, 2, 3, 4, 5, 6, and a little more. So that's going to be a focus. And I go 1, 2, 3, 4, 5, 6, and a little bit more down here. And there is my other focus. So now I can list the ordered pairs for those foci. So the top focus has an x value of negative 2 and a y value of, well, we measured this from the center, right? It doesn't land in a really nice spot, so I can't tell exactly what the y coordinate is. I can see that it's 2 point something, but we need to be more precise. The y value is going to be this y value of the center, which is negative 4. And from that, the way that I got up here was I added the square root of 41. So I'm going to take negative 4 plus the square root of 41, and all of that together is my y coordinate. Similarly, my second focus has an x value of negative 2. It's down here. And its y value is going to be negative 4 minus the square root of 41, because I went down square root of 41 units. And those are my two foci. Now I can draw my asymptotes. through the corners of this center rectangle. And through the center, of course. So let's list the asymptotes, the equations for those. They both go through the center, so that's going to be our point for our point-slope form. My center was the ordered pair -2, -4, which means in the equation I'll have x plus 2 and y plus 4. So my first asymptote equation is going to be y plus 4 equals my slope, which we'll figure out in a minute, times x plus 2. And my other asymptote is going to be the same thing. Y plus 4 equals my slope times x plus 2. Now I need the slopes. I need this slope. Okay, so let's figure that slope out first. Going from the center, I rise 1, 2, 3, 4, 5, and I run 1, 2, 3, 4. So my slope is 5/4, positive 5/4 for that line. The slope from my other one has to be negative 5/4, and it is, because if you go from your center, so you're doing this line now, I go down 5, which is -5 rise, and positive 4 run. Okay, so I've got my two asymptotes. I just need to finish them by getting y by itself. So I'll distribute my 5/4 on the right and subtract 4. To get 5/4 x minus 3/2. Same process over here. I'll distribute my -5/4 and subtract 4. And those are my two asymptote equations. And I've got all the parts listed now. I just need to draw the curve, right? I don't want to forget the actual hyperbola here. So I go through my vertices, wrap around my foci, and approach my asymptotes. So the top part's going to open up through the vertex and around that focus, and the bottom part's going to open down through the vertex and around the focus. You never ever graph inside your center rectangle. Okay, that's a good thing to remember. Your curve is always outside of that, pointing the opposite direction. So that is graphing a hyperbola from its equation and listing all of its parts.